So my name is Minas Hambardzumyan from Texas Instruments. My presentation today is on the topic of subscription-based testing with Kernel CI. This methodology was introduced relatively recently, and we at TI were able to use it to start submitting our test results to Kernel CI. So my thought with this presentation was to show how, an outsider kind of team was able to use these interfaces to effectively, start testing and submitting our test results and be able to take advantage from doing it. Sorry. This is our back slide, how we committed into open source. We are a member of multiple open source projects. We follow upstream first ideology, and overall, we love open source. I already introduced myself. The outline is I'll talk through the Maestro native testing flow, which Gustavo already covered. I'll just probably quickly skim through it. Then we'll talk about the new subscription-based flow and how TI implemented that flow in our CI system and show the benefits out of it. What is the objective, right? Why did we even get into looking into this? We are committed to maintain high-quality software in upstream for TI products. We want most, if not all, functionality that we deliver on our platforms to be upstream and in a working state, right? So the upstream first will get our stuff into the upstream source, but we also need to make sure that it still functions. So for that, we need to be able to continuously monitor the newest kernel versions and be able to monitor and react quickly to address new problems. And to us, the Kernel CI platform is well positioned to help us pursuing these objectives. Some of the key concepts, again, Gustavo talked through this, but these are the concepts that I will be referring to as I walk through my presentation. As you understand, Maestro is the central piece in Kernel CI to orchestrate the build and test flow. Maestro test labs are the labs responsible for executing tests requested by Maestro. KCIDB is where test results and build information is sent to. And then there is the origin concept, which basically is any company or organization who submits their information to KCIDB. If anyone starts using KCIDB REST APIs to submit that information, then they become origins. And then dashboards is the web interface to access it. You have seen this slide already. I think I'm just trying to show here that origins are basically both Maestro is an origin and any of these guys, which TI is one of them, is also origins, right? Because each of these has an interface that goes into KCIDB. And the labs, the important piece here is the labs are sitting there and waiting for Maestro to tell them what to test, right? They're basically passively waiting for instruction from Maestro to say, this is the, here's the, build that I want you to test. Here are the tests I want you to run, and they're just doing that. And for that to happen, this push functionality requires those labs to be, outside of your corporate network. They need to be accessible from the internet for Maestro to talk to them. A little bit about our internal test flow. We have a test farm with a lot of boards in there. These boards are connected to computers. We call them test execution engines. We have a centralized server that is capable of receiving test requests, allocating boards to run those tests. And then once the test is finished, those results are reported. And we have Jenkins services where the automation is basically, deciding what tests need to run, and controls this. All of this is running inside of TI intranet. We have no access from outside. And so having a Maestro-based lab, right, would be very difficult for us to implement. And so that's where the problem statement is, right? We cannot be a Maestro test lab because we are running internally to TI. We have our own internal tools that we're using, we are inside the corporate firewall. And so this event-based, subscription-based flow has helped us to overcome these issues and start submitting our test results. So what is it? Here in this diagram, I don't know how well is it visible, but at the top, I think you have already seen this. This is the exact same thing, a bit reorganized. Maestro is still running its flow. It's running its builds, submitting those builds into the storage and KCI-DB. And that's still is happening. What's happening on our side is we have a data source that contains a timestamp. This is basically last time we have checked with Maestro about new build events that have happened there. So we'll take that timestamp and ask Maestro through the REST API about the new builds that Maestro has created. Once that build is received, we will update our timestamp, right? And then we'll look at the parameters of that build to see if it's something that we want to test. Is it something that we're interested in testing or not? Assuming we are, right, we will now use the storage, basically information from the storage, the artifacts, the kernel modules and so forth to configure our tests, execute them, and then once the test is done, upload the test log to the storage server, again, using the storage REST API, and sending the test results to KCI-DB. And basically, this flow is repeatedly executing. We have Jenkins job basically running every hour, flashing through all of the tests, all of the build events, and testing whatever is applicable to our decisions. Here is more details about that flow, just giving you an idea of how actually this is happening. So the timestamp, as I said, is in a database. We just read it and update it. For us to talk with the Maestro APIs, we have to connect to the API, kernelci.org, and pass in information about what event is it that we're looking for. And the events properties are available. Basically, the build is now available for us to look at. It's a build, right? Limit is a number that you can set. Right now I'm showing 1, but you can set 100 or whatever. It just affects the size of the JSON file that you're receiving. Recursive true talks about how much information you want to receive inside of the JSON payload that you receive from kernel from Maestro. Once you receive all that, you basically receive a JSON file that contains information that you can use to find out if this build is something they want to test. And so you can look at the tree, mainline, in this case, branches master, which platform, which architecture, which compiler, which configuration, right? All of that can be verified, and we use our config files to basically drive, which ones we're interested in testing. Once we decide that this is what we want to test, now we're going to use the artifacts, configure our test to collect the artifacts from that build to configure the test. So we will take the kernel. All of this is still coming from that same JSON file that we received in the previous step. And we will also point to the modules. Device trees is a bit further away. There is a metadata property in the JSON file that has a link to another JSON file that you need to download. And once you download that one, you will see URLs pointing to your device trees. This is, I think, done because there is a lot of device trees. So if they didn't separate this like that, it would be much more larger payloads that you would be receiving. We're also using file systems delivered by kernel CI flow too. So, at the storage kernelci.org, there is a build root and Debian root file systems that we're reusing for our testing purposes. So you can see how we are basically running upstream tests, and we're not touching any builds, right? We're not really building anything here. We're just relying on the Maestro flow to be able to run our testing. Yes?
I was curious how often you update the build root or Debian images?
I think that's a question to Gustavo, maybe.
Oh.
The answer is I don't know. It's whenever we need to update something that's it's important for the test.
Yeah.
Yeah, but that's something that's maintained by the kernel CI with file system server.
We experience a difficulty in trying to keep that up to date because one of the challenges that we have faced in KDOps has been trying to provide the latest and greatest because we track different larger repositories that require a lot of requirements at build time. And essentially, the stable Debian images are not kept as up to date. So I'm curious whether or not it makes sense. I've been trying to collaborate with the folks from Debian to see if we can actually even get like builds with the kernels that we actually have from Linux history or Linux Next. That would be amazing because that would save so much time as well too.
But that would be only Linux Next, right? Because we end up building tons of kernels there.
Okay. So the point here, though, is that without us involving any type of builds, we're ending up having a full configuration for our test to run upstream kernel test for a very specific build and get some results. Once the test has executed, there is 2 steps we need to go through. One is to upload our test log to kernel CI storage server. Here's an example of the curl command for that. We basically create a path that matches to the structure or whatever we want to put it into. And we have to use a token. So that's a token file that we will receive from kernel CI team once you show interest and you're ready to start submitting your results. And then you will also send the test report to KCI-DB now. And on the right side, I'm showing here the structure that we're using to do that. And here you can see the build ID. This is the Maestro build ID, which will basically end up being help Maestro to understand which build is this test result, does this test result relate to. The platform information is there, right? And the compatible fields also there, which is compatible that comes from the DTS file. I think there is, Gustavo also brought up the question about how the platform's information is to be maintained in KCI-DB and how much more information, how do we standardize these names anyway, right? So that piece probably needs to be figured out better. I can pass in my job ID. This is actually the job ID of my job inside of TI. So if there is some problem, some reason for me to start going back and looking at what happened, I can use that to link to whatever was going on our side internally. And then the log URL. This is that same file that I uploaded in the initial stage. The timestamp, test result, and some little more information. Once this is all sent, now we are an origin for kernel CI. So what does this mean is that I can now go to the kernel CI dashboard, click on the hardware link, right? And I can see my company's name in like my origin name basically in there for the origins. As soon as I click on that, I can see all of my platforms here. And I can see which builds is it running for, and which tests, what's the status of the tests, passing or failing. You can also use filtering, the search functionality, by the way, and I found that it supports regular expression searches, so that's kind of nice. You can use the same web interface to get down to the details and find the test information, right? So this is one specific example where we have the boot test result. You can see history over past executions. Was it passing and failing? So it kind of gives you information about the stability of this test. And the rest of it is really, same information as what I was showing in the JSON payload that we were sending as a test result. In conclusion, it's really easy to become an origin for kernel CI. We have been able to use this to start submitting our test results. We find it as an advantage that we can use Maestro's artifacts instead of having to build it ourselves. Right now we're testing mainline and next trees, and we're publishing test results across 36 platforms and monitoring the results on the dashboard. For the next steps, we're looking to add more tests. So, LTP, K-sub test, those stuff. If you look at my, like 2 slides above, we did not have any test results other than boot tests. So we're looking into adding more coverage there. We will continue collaborating with kernel CI team, trying to find more effective ways to look at the results and catch regressions and easily access to the details that that maintainers and developers are interested to find, and catch regressions. One other topic that came up internally is about the bootloader testing. Kernel booting depends on bootloader, and so a question is kernel CI potentially a place where some bootloader test results would go into, and for us to be able to also look at that stuff, right? So might be something to look into. Some references in the slide, so you can find documentation on all. And a special thanks to Dennis and Gustavo from Collabora. They have been critical to making this functionality work, and overall kernel CI community for making all of this happen. Thank you. Any questions?
So you said it was really easy to become an origin. Is that really easy because you're Texas Instruments? Or is it really easy for, Joe with his little home lab that's got one device?
Yeah, as long as we have a lab, you know how to run it, like you can become an origin.
Do you have to get like authentication keys or something?
Yes. Yes, you have to get authentication keys. They have a staging server too, so you can start with, trying stuff with the staging server, see how it works, make sure your quality is at par for whatever you're trying to do. But once it's there, you're good to go.
You mentioned firmware testing. What are you looking for? Like, how much thought have you put into what you're looking for out of firmware testing or bootloader testing?
Well, I mean, we use U-boot, and U-boot has its own test suite. So, I mean, to begin with, it would be interesting to just be able to run that test suite and be able to see similar interfaces for U-boot results. Why have multiple platforms, multiple different views to solve the same problem? Looking at regressions, looking at test results.
Okay, thank you.
All right. Thank you.